thank you everyone for joining our AI speaker event today. My name is Henry, and with me is Hanchi.
Yep, I am Hanchi. And well, before we start, I'm going to go over how the event is going to be structured. So the event is going to be a AMA, which is a Ask Me Anything, meaning that throughout the next hour, we will be asking our guest, Ms. Winters, a variety of questions, and you will be able to join with your own questions as well. The questions should be about artificial intelligence, but other than that, you can be very broad. You can ask a lot of other questions as well. Anything about a career in AI or computer science, any other questions about innovations that are happening in the field. In order to ask a question, you can send your question in the chat. Now, since this event will be recorded and published, we will be able to relay your question to Ms. Winters for you. So if you're comfortable with being recorded, you can specify that in your message by adding an asterisk, and we will be able to ask you to unmute and you can ask a question for yourself. Otherwise, we will be able to ask the question for you. Thank you.
Awesome. All right, now I'd like to introduce our guest today, Dahl Winters. So Mrs. Winters is the Chief Technology Officer at DeepScience. She earned her bachelor's degree in biology from Duke and a master's in ecology from UNC. She's also an expert in applying AI to help the world become more sustainable and environmentally friendly. Thank you for joining us.
Thank you. Can everyone hear me okay? Perfect. So I thought that this would be an excellent time to just tell you all a little bit about my background and why I'm here to answer your questions today. I started off in AI back in 2011. I had almost minored in computer science. I then started a job at RTI International, Research Triangle Institute there in North Carolina. And I thought that it would be really cool to ride the wave of artificial intelligence that was occurring at the time. GPUs were just out. We were finally getting GPUs that were actually useful for doing machine and deep learning. And we started seeing software for organizing big data at the time. So Hadoop, Spark, and then the entire ecosystem kind of blossomed around then. So since then, we've seen artificial intelligence through a number of fields. And I was personally involved in geospatial analytics. I worked with satellite images and I took those satellite images and performed land cover classification using deep learning algorithms. TensorFlow, early on there was, before TensorFlow even really became big, there was Caffe, and so I used that. Then there was PyTorch. I started learning that as well. But basically, the speed of technology is just light. It's really a light speed today. It's impossible to know everything in AI. So I can give you a bit of a spotlight on my section of AI and kind of give you a little bit of direction into what fields incorporate AI and how to use those technologies. So what I hope I will be able to do for you today is just to give you some insight on one particular route through AI, but you will carve your own route. Especially in the fields of sustainability and especially in helping with climate change. There's a lot you can do with artificial intelligence, from utilizing big data with satellite images all the way to doing sentiment analysis or recommendation engines or using transformers to identify summaries of literature, of scientific articles. There's a lot of stuff you can do. So any and all questions you now have about a little less than an hour. So I'll let you guys fire away and definitely let me know how I can help.
So yeah, I wanted to begin actually by asking you a little bit more about the specific applications of AI in sustainability, because you listed off a few right there at the end. Can you tell us a little bit more about those? Because I think it might not be immediately clear how AI can have an impact in this field.
Yeah, so in artificial intelligence, you have machine learning, and then a subset of that is deep learning. Anything that you can apply statistics to, you can go deeper and use machine learning to understand how that data works. You can make predictive models of what happens within the soil or the atmosphere or the oceans. So one thing that's really important nowadays is, how do you deal with the carbon in the atmosphere? How do you pull that down and use it within carbon removal, making products from that carbon, or just sequestering it and burying it for a long geologic time? Basically, you need to model how those how the fluxes actually occur. And then you need to find, there's a lot of sensor data that's taken of humidity conditions on agricultural farms, soil carbon that's on those farms, the amount of soil and flux of CO2 that occurs into the atmosphere. And then of course you have forests, which take up a lot of CO2, and those forests take time to grow. So how do you make a predictive model of how your forest is going to behave in, say, 10 or 20 years to take up CO2? In order to do that, you need to identify your boundaries, the size of your forest plot. You need to count the trees that are on that plot, which you can do with identifying the shape of the crown of the tree through classification methods. So you're using computer vision to actually determine the shape of the tree. And then you can take that tree and then run alongside it a model of the tree growth. And then you can do a predictive model based on data that you've already collected to see how fast that tree will grow over time and how much carbon it should store. So that gives you then a way of identifying what your carbon credits might be in 10 or 20 years time. And also you can calculate, well, how much CO2 will you store? How much can you earn from your forest plot if you cut it down now, or if you wait 20 years to cut it down then? Or if you just make it into a conservation easement, maybe it might be worth more in 100 years. So those are the decisions that you can make with artificial intelligence. That's just one example. Soil carbon and forest carbon collection is kind of uniquely, that they're very well suited for computer vision techniques.
Kind of a follow through just quickly. You said one of the things was to count the number of trees, and I kind of identify it using their crown shape. I just thought it was interesting how you do that. What if just, what is the, I bet there is other applications to being able to identify trees specifically, but is that necessary if you can just perhaps measure the area instead of a forest area, so you don't necessarily count the number of trees, but just the land area, and kind of model how efficient that forest as a whole is in converting CO2 instead of kind of on a tree by tree basis.
Great question. You're absolutely correct for monoculture tree plots that are planted at the same time. So if you have a forestry patch and you're planting, like, say, loblolly pine all over that whole patch of forest or of clear-cut land, then you can expect them all to grow about the same rate, and they take up about the same amount of CO2. But the trend lately is going towards polyculture plots, mixed species plots that are more resembling natural biodiversity. So in order to do that, you have multiple species, which then you need to identify. And the only way you can really identify those multiple species are from characteristics that you obtain from satellite and aerial images. So different species, of course, will be a leaf during the year, during some seasons and not in other seasons. Some are going to have different reflectance patterns. And so all that data is ideal for incorporating into a classification model. And so random forest is something that's really good. I've used that a lot. You can then, of course, just do a artificial neural network as well. The downside of that is it is a black box approach compared to using a decision tree method. So if you want to actually understand what factors go into predicting where trees are, you kind of need to do like a more machine learning type approach without ANNs.
For another question, I was wondering, since you talked about basically trees and imaging, that's like basically applying sustainability with AI. So I've always heard of AI talked about as this field that is very diverse and it's very interdisciplinary. So I'm wondering, like, with your background in biology, how that has transformed into like specific insights you've had in AI, and how does that like help you be able to apply it?
Oh, very great question. So my biology background, of course, in biology, you have to take chemistry. And so I kind of went down the biology chemistry pathway a little bit during my time at Duke University. One of the things that I thought was really valuable in combining those skills with AI is the ability to use artificial intelligence for things like catalyst and just molecular discovery in general. One of the great things you can do with artificial intelligence is finding new molecules that will fit within a certain set of criteria. So for example, if you want to find a catalyst that's going to absorb or allow the conversion of CO2 into some other material, ethylene or ethanol or ethylene for fuels or for plastics, or if you want to just break that CO2 down into its raw constituents, carbon and oxygen. It takes a lot of energy, so what you need is an enzyme or some kind of catalyst to lower the energy hill in order to make your potential energy lower that you have to overcome to actually break down those break down CO2 into its constituents. So there's enzymes like carbonic anhydrase. There's companies right now that are making better versions of those using AI. So this is actually something that's very, very much it's a core use of artificial intelligence. Biopharma, big industry. You have drug discovery that's using the same kinds of software in order to find new candidates for treatments of various diseases. So sustainability is very much a great target for molecular discovery.
I'm wondering, with discovering different enzymes and stuff, like what type of machine learning model that is. Like, yeah, I just can't really seem to fit it in. Well, you know.
Yeah, it is. So there's a guy named Marcus Olivacrona, and he invented something, some software called Reinvent. This software, it's open source. It's one of the best examples of how to get into molecular discovery. And basically what you do is you can use any variety of machine learning algorithms as long as you are able to feed into it a particular feature. And as far as machine learning goes, you basically train your computer to look at features and then correlate those with particular classes or molecules or whatever the output is. So in doing that, you basically feed into, as a feature, a 3D molecular fingerprint, or something that's called SMILES. It's a string of basically atoms. Like sugar is CO something else, and there's like a lot of different numbers that go into that string. You basically take the string, you feed that in, you generate a molecular fingerprint using something like RDKit, for example, and then that molecular fingerprint goes into the algorithm as a feature. So, and then you can train based on a whole bunch of molecules that have similar properties. For example, I did one using this Reinvent software where I wanted to find different types of sugar molecules that were slightly different for potential artificial sweeteners. And while not exactly like a catalyst for sustainability, it is something that it was a very simple exercise to come up with like all the different sweetener molecules, so sucralose, sucrose, fructose, galactose, glucose, and then from that you can evolve new molecules and test out those molecules in terms of sweetness. And what I found was, I know it was working because it came up with a host of other molecules that were reported in the literature as being sweet that were not in my training set. So, I think that's definitely how you would do the molecular discovery. So just think about when you're trying to apply AI, think about what can you feed into your model as a feature, as a new feature. So it's all about features like that. That's how you basically teach your machine to recognize something. And then you just have, at the far end, you have your output, which is either different classes of material or like different, or you can even do like outputs, like three-dimensional outputs, as long as you specify what your output tensors are going to look like, basically.
That's very interesting. So I have another question to follow up with that, but then I have a chat question. So when you train these models, what kind of data sets are you using? And do you think that's a limiting factor?
Yes, definitely. So data is really hard to come by, good data. And you have to make sure your data is clean, that it's unbiased, that it is basically, you have to review and curate your data as more or even better than you do your model. The model's the easy part, but as far as the data, you can do images, text, or video. Those are like the main formats of data that you might come by. Those are all input methods into computers, and that's why we're able to use those. But for things like three-dimensional models, if you're trying to model the shape of a protein or something, AI was just used to basically come up with the shapes of proteins very recently. I think that was released by DeepMind, or I forget exactly, but it was a big thing. It was in Science magazine. But protein discovery, in order to do that, you have like this three-dimensional shape that then you have to feed into the computer somehow. So either you do that by images, text, or video, and the chosen method is text for that. So because proteins, you can break them down into amino acids. The amino acids all have different letters, different characters that then you can just put into a text string and feed it in. So all AI data is basically a variation of those three different forms. Geospatial data is latitude and longitude, that goes in as text as well. You can then take aerial images, that goes in as images, but you can also co-locate them with text information as vectors. So in sustainability, we're largely concerned with things like, well, how do we get the CO2 down? How do we prevent a lot of emissions? How do we expand renewables and have more energy that's able to be supplied? So in order to do that, we need to kind of identify what the data should look like, collect that data, make sure we collect it cleanly, perform our ETL, extract, transform, load, into some kind of system that can ingest all that data. And then you can then select, well, based on your data, what model are you going to use? What kind of machine learning algorithm? Do you need something that gives you a black box approach and higher accuracy, which is typically deep learning? Or do you need something that is going to be faster, maybe less accurate, but easier to understand, which is things like random forest, support vector machine, and decision trees in general. So those sorts of things kind of you have to think about and weigh the pros and cons of each approach. But it's very much dependent on your data, as you mentioned.
Then I'm gonna pivot here a bit. We have a question from the chat. So he's going to be asking about like basically how to choose his own career path through AI. It's about colleges. So I'm gonna ask him to unmute now.
Excellent.
Go ahead.
Oh, hello.
Hi.
My name is Johan, and so I just received my offer from NC State University and the UC Davis.
Mhm.
So from the ranking, UCD have much higher rank. I mean, in CS major is much higher than NC State. So I was wondering, like, will that ranking affect? I mean, will that ranking matter a lot in my future job and my career? Or and also I want to ask, like, how is NC State graduations in, like, how is like graduation from NC State like yeah, NC State graduation students good, like, I don't know, good worker in companies and all these things.
Yeah, I definitely that's a great question. So I would start by looking at the departments that you plan to apply to in both of those schools and see what the rankings are of those departments, not the entire school, just basically what the data science or computer science or whatever you're going into, what the rankings are of those. Now, to really decide, ranking is just one factor. You really want to know, like, what professor you're going to have who might be teaching in classes, who you might be able to do undergraduate research with. Do they have time, or are they busy doing their own research so they won't have time to devote to your education? That's another factor in deciding. As far as NC State is concerned, I know a professor there, James Lester. He's outstanding. Definitely has grown that particular department of AI by leaps and bounds over the last 10 years. So James Lester is he does, I believe it's educational use of AI within education. And he does things like use of games, visualizations, and other things to aid the educational process. And he solidly incorporates AI into his work. UCSD, or the university that you mentioned earlier, I don't know specifically about their programs, but they are pretty solid as well. So you kind of have to see what, between those two universities, what projects you might be interested in pursuing, and what people are there to support you on that.
Okay. I have another questions, but so about UNC, like, if you actually get into, I mean, I don't know if you know the answer, but if you get into the UNC, like, yeah, I know they are going to have a, like, if you want to go to the CS major, you need to apply. How competitive, like, you have to be in order to get into, like, CS major at UNC? Do you know anything about it?
Yeah, I know about UNC because I attended there for my master's, but I was in ecology, which is not quite the same as computer science, but I did attend a number of courses in geo programming and some overlapping courses with computer science. It's very competitive. It's probably more competitive than NC State, but it's a great school. It's a great program. You're going to learn a lot, but I wouldn't choose based on just how competitive your college is or university is. Definitely look at the programs that they offer. And you want to get into the highest possible ranking school as you can, but if you don't get very much out of it because there's not very many professors with time to help you through, that's not really worth it. You spent 4 years for, like, teaching yourself how to do AI. So definitely think about the trade-off there.
Okay, that's very helpful. Thank you.
You're welcome.
So in a similar direction, before the events, we did talk a little bit about how you got into AI, and I thought that was a very interesting discussion that you might share with us. So you went to Duke and NC for biology and ecology. So how did you get into AI after that?
Yeah, good. This probably applies to a lot of people out there. Those of you who are lateral entry into AI from various science fields will find this very interesting, what I'm about to describe. So when you're in college, if you're taking a different subject other than computer science, you want to take as many computer science courses as you can, to the point of even minoring in computer science if you can, because it's important to have that computational background. You need to learn how to code. If you don't know how to code in school, you'll have to learn later, which is a lot harder to do. And you will probably miss a lot of things that experienced software engineers know about. So that's the downside of self-learning how to code. So you want to do that in school. And taking courses like that, like programming courses in computer science, will help you in college. Now, after college, when I use my biology and ecology skills as subject matter areas to focus my computer science interests, I was able to then do computer science in the context of ecology. And what that means is I used a lot of geoprogramming in Python and in C within ArcGIS and Quantum GIS, QGIS back then. GIS is Geographic Information System. So you can tell by the name that you're really getting into some computer science there. So even though I was in ecology, my whole degree was focused on research that had to do with geographic information systems and remote sensing. So I did a lot of satellite and aerial work. And so when I got out of my master's degree program, I went to Research Triangle Institute, RTI International, and there I learned how to actually hone those skills towards practical problems. So I received a lot of on-the-job training. And then in addition to that, I also took an interest in big data, and particularly geospatial big data. And that led me to apply to a job at what was called Digital Globe back then. It's now Maxar Technologies here in Colorado. And so that took me cross country. They paid for me to relocate, to work there for tasks that involved satellite image recognition, basically, and land cover classification. So I was an R&D scientist for a few years. Then I started, I decided, well, I'm doing this and other innovation challenges. So then I started a business around solving problems using AI. And it was around that time I had a client come up and say, well, we'd like for you to design a cloud system for us that's going to do crop classification. And that was really where business kind of took off after then. But it was all because I had an interest in using AI and solving problems using my using subject matter expertise in biology, ecology, chemistry, those sorts of things, but really maintaining a strong underlying focus on the tools of artificial intelligence and programming. So all of you who are thinking about doing artificial intelligence but have a lot of skills in particular areas, think about how to use those skills in the service of that area that you're interested in. So even if you're an English major and you want to know more about artificial intelligence, read about sentiment analysis, read about transformers, BERT models, those sorts of things. You will get so much attention in as well as diversifying your abilities in your career path. So an artist, learn about Deep Dream and how that works, basically. Google put that out, and it's really cool. Invent your own technique around that. There's applications of artificial intelligence in every field. And my particular path is within sustainability and climate change, because I know that we have a problem that we need to solve. It's global, it's massive. And the only way to solve it is really through a combination of tools and getting people on board. Basically, because we're all people who are emitting. We need to kind of tweak our emissions, lower them, quite a bit, and AI is one of the tools that we can use to do that.
So you went into AI after focusing more on a college. So after focusing on your application, the area where you're applying it, and then you kind of went into AI and brought that into your subject.
Mhm.
But I think some of us, including me, are going to college with a focus in AI. So like I plan to major in computer science and concentrate in AI at schools that have that. So do you think it's necessary to kind of learn AI understanding with a understanding that you have to find a field that you want to apply it in? So you have to also find, kind of major or minor in another field like finance or something that in the future you can apply AI in? Or do you think it could be as effective to just learn AI, get a really good understanding of deep learning, and then once you have that, it's basically a versatile tool that you can apply in any field. So you don't really need specific subject matter knowledge in those fields that you apply the AI in.
Mhm. Yeah, I think that you're free to do both, and there's definite advantages to getting a deeper dive into AI, and then just applying AI within the field of AI. So, for example, Yama Kun, Andrew Ng, all the big Yoshua Bengio, all the big people who are in AI, they don't really have another field that they develop their ideas in. They are core, like really deep into artificial intelligence and developing new techniques to help that field grow. Now, so you don't have to actually have an application area for AI, but it really helps if you think about if you're more of a generalist mindset and you want to pursue other areas as well, you have another area that you're really interested in, it can help to have a subject area that you can focus on. And especially when graduate school gets kind of tough, and then you're like, well, I've been working on this thing for like 10 years, and I'm here doing this degree, and degree is taking like 4 years, and it's like really hard. If you have another subject, you can kind of do you can take your time and work on that, and you have a break. But if you've only focused on one thing for the whole time that you've been in graduate school, college, and then graduate school, and before then, and it doesn't work out, for whatever reason, maybe you're something happens, goodness forbid, and you have a family or an accident or something, it doesn't work out. Having that extra padding of knowledge can be helpful, but it's not necessary. It's entirely the great thing about being in the free world is that you have the freedom to make your own decisions. And really, people think that, well, just because you need to get into a good school to get a good job, to get a good house, to get a good, family and everything else. But really, we all have choices to make, and we just have to do the best we can, and make sure you enjoy what you do. That's the most important thing. I really enjoy what I do. I have nobody telling me I need to get up at a certain time to do whatever, except I need to do stuff for my customers. But I really, AI should be a tool to use towards the end of actually living a good and prosperous life, and not the other way around. You don't want your life to consume all the time you spend because you're at work doing some AI focused tasks that you might not enjoy, because life is like that sometimes.
Cool. I have a question about just generally. You mentioned that you were involved in a lot of competitions that applied AI, and I'm wondering if it's a good thing for high schoolers even to start thinking about these things, like with like local hackathons or things like that. What do you think they could do for the high school student, and some ways to find them?
Perfect. Yeah. I love that question, because this is one of the few areas that is really geared towards high school and college students. Hackathons are just basically big, massive water holes for people to gather and showcase what they can do with the skills they already have. And if you don't already have skills in a particular area, you can team up with those who do and then learn from each other. That's the cool thing about hackathons. There's DevPost, they list hackathons all the time if you're not already on DevPost. There's Driven Data, which does a lot of data-oriented hackathons that for data scientists and data engineers. Those two are like the ones that I would, Top Coder has some good stuff as well. Just look at those and see, try to expand your horizons a bit on like, find a good project that you might want to work on. And then that's basically how I got the job at Digital Globe a long time ago. I had a project that I came up with and I just decided to investigate that. And I actually had a product and output from that I could showcase to the company that was hiring me. So without that kind of background, if you don't have a GitHub profile, if you don't have like something that shows what you've been able to do, it's that much harder to convince companies to hire you for a particular task, even though it's an entry-level position. So so you really have to just do what you enjoy doing, make it into a project, and then showcase that project. So that's definitely, I would advocate that high school students everywhere look into those hackathons. They're pretty fun, and occasionally they award prizes as well. So.
Can you tell us a little bit more about what deep science does? The kinds of technology that you make and models that you work with, as well as kind of the impact, the real world impact that you are having with AI.
Yeah. So Deep Science, we were founded in 2015. We have 3 different tracks of focus that we have. One of them is just core data science using artificial intelligence to solve and improve scientific workflows. So basically that's data science for science. We also have open innovation, which occasionally uses some AI tools as well, but that is mostly geared towards our work that we're actually doing on biomaterials for implantable devices. To design those biomaterials, we do use some AI to narrow down the subset of materials that would be useful. And then we also use computers to model the chemistry, as well as to figure out like how thin the membranes have to be for various applications to allow diffusion through and such. So that's open innovation, data science. And then the last thing, which is most recent, is the carbon removal that we've designed a sorbent that actually takes CO2 out of the air. We're working on characterizing that to see if it's going to be worthwhile or very useful. But we think that just modeling how basically the process and the flow pattern of the CO2 through a device, that can use some pretty advanced modeling as well. But basically our main tools are, we use deep learning for any kind of geospatial big data work that we do. We use cloud resources, and we also have some in-house resources. We also do, for the chemistry work, we have software for that. And so, and then there's custom tools that we also design on occasion, depending on the application. So plant counting, crop counting, tree counting, those are all very easy. Identifying species is a little bit more difficult, requires more data. But basically any data that a customer comes to us with, we can probably design some kind of AI solution for that. But we don't actually collect the data ourselves.
With some of these tools that you mentioned, I was under the impression that AI and computer science are not like separated fields, right? And it's not like one or the other. So what are some of the ways that they could like interact, some traditional tools that you use in combination with AI?
Yeah, I see AI. AI is definitely it's a subset of a computer science field, but AI. There's like core programming, and then there's what you do with those programming tools. So like web development, for example, you wouldn't consider that AI, but you can run machine learning applications using TensorFlow JS. So it's definitely a blend of what you would do with computers for the web, for the internet, utilizing AI. So that's one area of overlap. I would say that for additional areas, there's computer engineering that is not quite computer science. It's the hardware component of making computers. You need to process, optimize how you're actually going to make those chips. Right now, we have a massive chip shortage worldwide. And we have a rare earth metals shortage everywhere as well. How do we actually streamline those processes such that we use the least amount of materials to produce the most product? Recycling those materials and such. Those would be things that fall under computer engineering potentially and could have AI solutions. And I'd also count those under sustainability as well, because if we're not able to produce chips for our cars or computers, maybe the next iPhone might be your last. Hopefully not, but you definitely want to ensure that everything flows smoothly, the economy runs and everything. So we don't want the next iPhone or Android to be your last. Mostly, definitely not.
Do you think, so in AI, I think there's been a few moments that have really pushed the, it's not gradualism, it's punctuated equilibrium, big leaps, I would say.
Yes.
And I think at the beginning of this seminar, you talked about GPUs, how when they first came out, they unlocked a lot of AI because of their sheer compute power. It is much more efficient to train models on GPUs than CPUs. So in kind of AI and sustainability, or just AI in general, what do you think are some bottlenecks that still exist that could become, once cracked, could lead to big jumps in the field?
Yeah, the biggest one, I'd have to say the biggest one, especially in AI and sustainability, is the efficiency of the compute that's used for AI. That it's a big problem because when you, for example, transformer models, if you go to use a BERT model or one of the newer ones nowadays, which basically require thousands of computers with GPUs that are just consuming megawatts of electricity. That's really, it's not very efficient. And compare that to like the human brain, which basically uses like 6 watts of energy, or I forget exactly how much, but you can tell how inefficient we are in building our computers in order to do AI. That, I think, is by far the biggest bottleneck that we face, is the efficiency of our compute. GPUs made things so much better, so much easier. Before then, we really didn't have like the explosion. It was like the Cambrian explosion of compute power for artificial intelligence. That was what GPUs essentially were. Over time, we've had other methods, other incremental methods to increase compute power. By doing distributed computing versus like one single supercomputer, we can use commodity hardware to do AI across many different machines. That's an incremental improvement. We also have things like there's other advances within chips that make them neuromorphic, for example, so such that they can do different tasks, which with much less hardware being devoted to that. So all of those things, I think, are things that we've overcome. But the main thing that we kind of need to overcome pretty quickly is not having like data centers full of computers doing processing for one particular problem. It's highly inefficient use of resources. We want all those data centers doing like lots of problems, which means we need smarter software as well as more efficient hardware.
On the note of more efficient hardware, what do you think the future of that is? I've heard of some companies developing like analog chips, and I'm wondering.
Yeah, if there are basically chips that are massively parallel, that perform a lot of parallel computations, that's probably where the future of computing will lie. That kind of in a way mimics how our brains work as well. Each neuron has like multiple functions, and part of being part of a circuit that stores memories, that does other things. You can't just have a transistor do one thing, which is turn on or off. You need it to store data. You need it to actually be like some kind of a component in a much larger system. And right now, most of our chips are, as smart as they are, as complex as they are, they're actually pretty dumb, because the only thing that you can do with our chips is like the one function that you send to it. You have to give it software, and then it does something with that software, changes ones and zeros, and then gives an output. But you basically can only run one program at a time. What if you could do multiple programs on that one chip, using that one chip? Maybe you might have to redesign the architecture of your of how you're actually feeding in data. But the human mind just, we have a lot of neurons. There's like 100 million neurons or so, but each neuron does many different functions at the same time. Now we don't actually have our brains don't work the same as like artificial neurons by any means, but we do have like similar things that we try to mimic. And the brain has had many more years of evolution than we have in AI. So kind of makes sense to do things like spiking neurons, potentially neurons that are time dependent in their signaling. Maybe we can design our architecture around that as well.
Yeah, I think it's, it's interesting how, you're using AI to solve these sustainability problems. And, obviously we talked about the efficiency of the brain, but you're using AI to solve problems with the world's efficiency, but you also said how AI itself has an efficiency problem. It's kind of a very interesting dualism.
Yeah. Very true.
Yeah. Do you think that let's see. So human brains are really, very different, very flexible, but very, very powerful, but also low energy systems, in the sense, like you said, 6 watts. So do you think that AI should try to copy that? We should try to design an AI that, because deep learning in itself is sort of an analog to neurons and in the human brain. So in a way, it is inspired by that. So do you think the holy grail of AI would be creating an AI that functions efficiently, that thinks like a brain, that acts like a brain? Or do you think that's just not really important? And perhaps more importantly is how AIs complement brains in different ways with their unique strength.
Yeah, I'm more inclined to think about the latter, just because whenever we design, we kind of design as a tool to help people when we develop AI. and we don't really need to mimic nature to do that. We just need to design a tool that does a really good job, a very great job at being what it is that can complement humans. With that said, I don't think that that precludes doing tasks like trying to make machines smarter. I think that definitely that's another track that you can go down in your AI careers. That is, we've developed convolutional neural networks from actually looking at how the visual system works in humans. That kind of inspired the direction, and we found out that yes, there are like these little layers that act as the layers in deep neural networks as well, that pipe in information and pool them and do other things. But we don't necessarily have to be relegated to just one architecture. I bet in octopuses, within like sea creatures and insects, for example, that have to deal with complex situations with very minimal brain power, we can find some good other analogs to strengthen our AI capabilities, other than trying to mimic the human brain. I think there's a lot to be said for like Caenorhabditis elegans, a worm. It was basically, it's a flatworm that has had all of its neurons modeled, and you can basically show how it takes 12 neurons and actually makes a reflex pattern. Very, very efficient use of 12 neurons. I forget the researcher who did this, but it's stuck in my mind, like how that is like the example of what we want to do with AI. We want to basically retrain that 12 neuron set to navigate a car, for example, which has actually been done. A toy car has actually been steered with 12 neurons. Imagine what you could do with a self-driving car and like say 1,000 neurons if you have a similar architecture. My thing is, we do not need to have like 10,000 computers chugging away at some problem. We could probably do it for like 10 computers smartly working to solve that same problem, and then be more sustainable as well as while we're there.
You talked about like a lot of different types of AI, and I mean, sometimes even the goal isn't the same anymore. Sometimes it's trying to mimic the human brain. Sometimes it's just to do a particular task more efficiently. So do you think that in the future, AI is just going to be split into a lot of different fields that are going to be separated? Or do you think there's something central about like what AI is that would make them sort of stick together?
Yeah, I would say speciation occurs all the time. We take one species, we make like lots of different species from that one. That's kind of where AI is right now. We have this tool, artificial intelligence. Intelligence is really broad. There's many different ways of describing intelligence. We're trying to create an artificial version of intelligence. It's probably necessarily going to go in many different paths, but all of those paths will be united by a few common concepts that you'll learn in college and graduate school. Learning to code is definitely how you can converse between all those fields. So yeah, there's definitely something to be said by having a core area of AI knowledge. But people are going to apply it to so many different fields. You will have many different paths to choose from.
So I think it's about time to wrap it up, but thinking about the future, what excites you about AI the most?
I think the people on this call really excite me. I have not seen all of your faces. I don't know exactly who you are. I see one person I know on this call, but I am really excited by the potential that you guys have, and you gals, to work in the field of AI to make the next generation of developments. Because people think about AI as being something that takes away jobs, takes away, people's ability to hold on to their data and data privacy issues and such. But I actually see AI as an opportunity to strengthen our ability to have better jobs, to be smarter at those jobs, and to practice ways of like anonymizing our data such that we have more privacy in the future. There is definitely a lot to be said by having so many smart people on this call. And I'm just privileged to be able to speak to you guys. And hopefully some of you, all of you, since you're all on Salia and you're all interested on about AI, will take that career path and explore it a little further. And I'll be here if you guys want to reach out, ask me questions later, connect with me on LinkedIn. I'm sure that when we wrap it up, you guys can give me give out contact information for me and such, and we can continue.
Indeed. All right. Well, thank you so much, Mrs. Winters, for joining us. It really has been a great time, and I appreciate you spending an hour with us. So yeah, like you said, if anyone has any more questions to ask, you can. I will be giving out Mrs. Winters' contact information, so you guys can contact her and send her any of your questions. So with that, thank you everyone for joining, and I hope everyone has a great weekend. Thank you. All right. Thank you.
We have one person joining still.
Okay.
All right.
And you're still recording, by the way. You might want to cut that.
Yeah. Wow.
All right. Let's see. Whoa. All right,
Last
well,
you made though about
yes, I think we're yeah.
can we talk a bit more?
We'll
I
try
guess.
that. That's fine.
Yeah.
Yeah.
Wow.
But yeah, thank you. That was a great thank you for your time. That was
Yeah.
that was great. I really appreciate it. I hope you enjoyed it as well.
I did enjoy it, yes. Definitely a bright, sunny day outside, but it was even sunnier here just speaking to you guys. So really pleased.